I want to talk about a photoacoustic CO2 sensor that I designed. The photoacoustic CO2 sensor works on the principle of the photoacoustic effect. The photoacoustic effect was discovered in 1880 by Alexander Graham Bell. That photoacoustic effect actually works when modulated light passes through a sample. In this case, we're talking about carbon dioxide. When that light passes through the sample of carbon dioxide molecules, it excites the molecules of the carbon dioxide from lower energy levels to higher energy levels. And these higher energy levels, these molecules are going to de-excite. Now, this de-excitation or relaxation can take place in different ways, but the one which dominates and which is of interest to us is the non-radiative relaxation. Now, this is also called collisional relaxation. Now, this is where the molecules collide with one another, and that causes an increase in kinetic energy of these molecules. This increased kinetic energy actually leads to an increase in temperature, and there's going to be variation of that temperature, which is based on the frequency of modulation of the radiation. Now, the increased temperature also leads to increased pressure within the cell or the chamber where the gas is, the CO2 is. Now, this pressure variation leads to a generation of an acoustic signal, and this acoustic signal can be dictated through the use of a microphone. Now, in my particular application, the light source is a mid-infrared LED because CO2 has a characteristic absorption signature in the mid-infrared of about 4.26 microns. And there is an electronics that I designed that leads to the modulation of that radiation at the frequency of interest based on the cell design. Now, the cell is designed for great maximum acoustic signal generation, and the microphone is placed based on my design at the middle of the cell where we have the antinode, that's the maximum acoustic signal, which can be generated. From the microphone, when the signal is dictated, what happens is that there is signal processing and signal display. And there is an electronics that is there which are used for that, which is the locking amplifier that ensures that the signal that is dictated from the microphone is not lost to the background signal. And then there's a signal display which can be displayed on a laptop, a computer, or whatever way we want to display it. It can be printed as well. So basically, in summary, that is how the photoacoustic CO2 sensor that I designed actually works and operates. Thank you very much. Bye.